Oh, good evening. So it's always fun to be here talking about some aspect of astronomy. In this case, aurora forecasting, sort of that season with increasing solar activity. So I just put in, I carefully titled it Some Perspectives. That means I can choose what perspectives I decide to talk about. So you'll see what I mean. So let's get on here and a bit of an outline. And so I'll start off with a bit of a cause of aurora. I'll skip a lot of details. I know it's a huge subject, and so I will try to minimize some details and maximize some other details. Causes of aurora is basically the sun, but sun causes a solar wind to come toward Earth and affect Earth's magnetosphere. So I just put in one picture of a solar disturbance. In this case here, you see the upper right picture. Nice big disturbance leaving the sun, and the solar wind, instead of thinking of it as a wind that blows directly from the sun toward the Earth, think of it as a huge whirling plasma with mixed up magnetic fields, and it's a big spiral away from the sun. And any disturbance on the sun, any particular location, may or may not be facing the Earth, or by the time the disturbance reaches the Earth, it may or may not be so-called geo-effective. So there's a huge amount of solar activity that I decided to leave out, from sunspots to flares, major flares, to coronal mass ejections, to coronal holes that I'll just mention briefly in passing. So the main point ought to be that the solar wind magnetic field has to couple with the Earth's magnetic field in order for energy and particles, charged particles in that disturbance, in the solar wind, to enter Earth's magnetic field and affect the atmosphere and cause glowing light. So those disturbances happen when the solar wind's magnetic field is oriented carefully to couple with the Earth's magnetic field. So I threw in a couple of illustrations to illustrate that. There's some other details that are related to chemistry, which I decided to leave out, about the interesting fluorescence of the Earth's atmosphere, but we don't need to go into that too much. So you saw this graph already. Sunspots are a huge impact, and so it's just worthwhile to mention that increasing solar activity right now, this year, is causing increasing chance for aurora in general. And so I put in a few cartoons here to illustrate increasing complexity of the Earth's magnetic field. So if you start with the upper left and you say a cartoon diagram shows a dipole magnet, that's a quick picture of the Earth's magnetic field. And in more complexity, when you look at it on the right, solar wind's magnetic field is blasting into the Earth and causing some interaction. And of course, in the bottom, there's quite a bit more interactions visible, and didn't want to explain them all. The main point, as I said, is that when the solar wind interacts just right with the Earth's magnetic field, then we get the energetic particles in the disturbance that's in the solar wind pouring into the Earth's magnetic field. And so, huge amount of detail. I decided to skip it all and just say that when that happens, we get some chance for aurora. And the point is to forecast it. So most of the presentation here is based on government forecasts of aurora. So you'll see what I mean. I said most of it, and I have my own forecasting technique at the end. So I just did many complexities, and here's another illustration, maybe more colorful, of the solar wind interacting with the Earth's magnetic field. And it has to happen just the right way when magnetic field of the solar wind becomes negative oriented or southward oriented. So I said it's basically all the predictions are based on the government forecasts, and they come from the Space Weather Prediction Center. So you may have heard of it, may not. I'll show quite a few illustrations from it. The main reason I mention this is because almost every app and website I've seen that tries to forecast aurora based it on predictions from Space Weather Prediction Center. So that's what I'm using here. So that's fine. It's worthwhile to keep in mind some complexities here. And the KP index, KP is what I see quoted most often. There are several problems with using that as a forecast technique. It's not really very good because it's a measure of the planetary activity, not the local activity. So you can pull up information about more local magnetometers, such as Boulder, Colorado, or some spots in northern Canada, and get a better picture than the global average, which is what the KP is. And the other detail to keep in mind that KP is a 3-hour average of the average magnetic variations. So if you get an aurora that's, say, blasts up for, say, half an hour or 15 minutes, it may or may not show up in that 3-hour index. So those are some little faults to keep in mind, or imperfections. But meanwhile, the KP index is used quite a bit, and so you see graphs like this that show it every 3 hours for typically for a 3-day or sometimes a 24-hour back period. So this is a recent screenshot, and so you see it fluctuates every few hours from 2 to 4 basically most of the time, typically. Interestingly, a couple of years ago when we were at the quiet period of the solar maximum that you saw in the sunspot diagram that both Arnold and I showed, pretty often this KP index was 0 or 1 for quite a long time. So we're entering busier times for magnetic interactions that may cause aurora. Despite the imperfections that I mentioned, KP index is used pretty often, and as just as a very general guideline, the pictures are intended to show KP3 on the left and KP5 in the middle and KP7. And so the auroral oval pictured in these auroral oval forecast predictions show KP3 causing auroral oval to be fairly well north of the Great Lakes area on the left, and KP5 near the Great Lakes, and KP7 not only over or south of the Great Lakes in the image on the right, but also quite a bit more intense. So the red means a higher chance for aurora to be seen underneath that auroral oval. So that's just a very brief thumbnail sketch of the difference between KP3, KP5, and KP7. So although I don't like to use them, and I say a few negative things about using the KP, including this comment that it's only quasi-helpful, it is used in widespread use for aurora forecasting, a little bit imprecisely in my opinion. So here's a question: when you see KP index was 4, 5, or 6, or 7 for the past 3-hour period, does that mean aurora is active in your sky? And for how long? And I mentioned the problem of aurora becoming pretty bright for maybe 15 minutes. Does that affect the 3-hour index? These are just some of the imperfections you have to deal with when you interpret the KP index. And problem I've seen in the past 10 years is that whenever we see KP index of 5 or 6, I see some photographs show up on websites like spaceweather.com or others. I think of them as photographic aurora. And if I've seen a few of them as a visible aurora, it's just a puny little, tiny little, barely visible aurora. So, so I think the KP index is a little bit misleading, but that is the best forecast parameter that's being used widely. So that's what we're working on. So I just wanted to point out those little imperfections. So I just put in an example here. Suppose the time is 9:30 p.m. And so it's UTC 0130, and the latest KP index was 5. And so that means it was for the 3-hour period ended at 8 p.m. And so KP5 is fairly significant. It indicates minor geomagnetic storm conditions and very disturbed geomagnetic field. But what use is that for forecasting, or what does it tell you about what will happen now if you go outside now, or 1 hour from now if you're going to drive somewhere to a dark site? So is it any use? Maybe, maybe not. Anybody want to guess? If not, just advance to the next slide. Okay. So to answer that question, I would need some more details about the solar wind. I would want to know what's the magnetic field strength and orientation. So remember, I tried to point out very briefly that the main impact of a solar wind that we need to be concerned about is whether it interacts with Earth's magnetic field or not. And it does when it's south pointing. So most of the time at normal equilibrium conditions, quiet conditions you could call it, the solar wind is oriented north pointing. But when it's got all these disturbances in it from the solar disturbances that cause magnetic field disturbances in solar wind, it could become south pointing. And when that happens, it's set to couple with the Earth's magnetic field and allow all that energy in that whirling plasma to pour into Earth's magnetic field down the field lines into the atmosphere and cause glowing light. But I also need to know the speed and density of a solar wind. I think those are critical to understand to try to forecast the whether or not there'll be any aurora. When KP5 seems to be sounds pretty interesting. And so I'll just briefly mention there's quite a bit more than a couple of satellites, but these 2 satellites were sent to sit in the L1 Lagrangian point, sort of pictured on the right here. L1 Lagrangian point is where they're sort of stationary relative to the Earth. So there's sunward of the Earth, and they sit there more or less. They actually sit in a little halo orbit, as you can see in the lower left with that picture of the ACE spacecraft. But the point is, those 2 spacecraft are measuring solar wind. That's their job, that's their intention, and they're setting back data which we can interpret full time because it's publicly available. So the ACE and Discover are the main satellites whose data I'm using here. So here's an example of real-time solar wind data that we can get from the website, Space Weather Prediction Center at NOAA.gov, and some other products. I'll point out a few of these, but most of them come from SWPC. So the point here is, excuse me, the point here is, you see BT, or the total magnetic field strength, marked off in that black line at the top. And it doesn't really show up here. Maybe it does. Maybe I can get it here. BT. And the BZ is the vertical component. If you think of the solar wind coordinates in Cartesian coordinates with X, Y in a horizontal plane and the Z coordinate, and the vertical pointing up or down. The BZ is pointing upward. If you see it positive here, then it's a sort of normal situation where it doesn't really interact with Earth's magnetic field. But when it becomes southward pointing, or BZ becomes negative, or the Z component becomes negative of that magnetic field, then it's set to couple with the Earth's magnetic field. So we're really looking for BZ to be negative if there's going to be any chance for aurora. And so here's this plot for a one-day period, and this is a fairly recent situation. It'll probably be copied yesterday or a couple of days ago when I was setting up the presentation, but it's a very good illustration because BT is not very strong. I really want it to be well above 10 nanoteslas on this graph before there's any real chance for aurora. And I want BZ to be negative, about negative 10 or stronger to be any real significant chance for aurora. So here you see it diddy-bopping around, just fluctuating around, not really strongly positive, not strongly negative, just sort of interestingly fluctuating quite a bit. And it has been a disturbed condition for the past few days. That's fine. So the other detail I want to look at is density. So the solar wind density is a straight line here, more or less, approximately. And the speed, generally I use 500 kilometers per second as a rough guideline, where if it's faster than 500 kilometers per second and some other factors are in place, yes, there's a good chance for it to cause aurora if it's going to do that. And if it's slower than 500, it won't really. So this is an interesting period the past few days where speed is genuinely above 500 kilometers per second. And BZ has been negative. So anyway, that's just an illustration of the real-time solar wind data. I think I have a couple more. That was Discover, I believe. And this one, I think, is it ACE? No, it's Discover again. Okay, so I threw in the example for March 23 and 24. And so just out of curiosity, did anybody here see that bright aurora on that Thursday night? Okay, maybe not, maybe. So the point here is it became pretty darn interesting on the night of March 23rd, around 11 p.m. Local time, and there was a big aurora outburst. It was quite visible, even from my light polluted yard where I live. But the point here is I put in the arrows to mark off the time of March 23 to March 24. And it's a very interesting, it's a very good example that I put up here to illustrate how I use the data to forecast the aurora. So here, it doesn't show up so well on this graph, but I have a better one. But look how high BT became. It became up around 20 nanoteslas. That's where I wanted it to be. And the BZ became sharply negative after that. And density graph showed classic shock wave. So a shock of increasing particle density hit the Earth's magnetic field, or actually hit the location where those spacecraft are, and the Earth about half an hour later, roughly. And that's what's a great picture for an aurora. Speed, it's already well above 500 kilometers per second, or it's pretty close to it. So certainly within the guideline that I think is pretty reasonable for causing aurora. So classic picture right there for that particular period, which is a rare aurora. So recall this, I showed you all this earlier. So I showed you this stuff here down to here, and I said, what about now or 1 hour from now? And so now that I've pointed out that we need to be aware of the solar wind information, I want to know what is the latest BT, BZ, and solar wind speed. Remember, BT is the total magnetic field strength, and BZ is a Z component. And B, just so you know, is in physics, is the capital B is used to represent the magnetic field. So BT and BZ and solar wind speed, that's what I want to know. So I can just open this website, swpc.noaa.gov. I mentioned this one as a classic reference website because all the others that I've seen, all the apps and websites use data from here, use the exact same data that's here or older. So this is, open up that and it shows at a glance, current solar wind speed, current BT, current BZ, is it negative or positive and how much? And furthermore, the flux, and I'll mention the solar flux later end of the presentation. So all this is available at a glance because it's important. So fine. So now I'll show a few online resources. I didn't try to list all the websites and all the apps. I just picked out a couple that I was able to successfully download the trial on my iPad, although I couldn't get one of them to open and work. But it doesn't matter because they all show the same thing. All the data I just showed you is what they show. So they provide links to the latest KP, forecast KP, and it's almost all from NOAA SWPC. And some apps even provide the latest solar wind info. And by that, I mean that some apps don't do that. So I really think you need to know that, or at least I need to. Now, understand some people in the room are not physicists, chemists, and say, never mind all this garbage nonsense about magnetic field. Just tell me, is there going to be aurora or not? And that's the popularity of the app, and they try to do that. So, okay, I understand that, so fair enough. Back to the SWPC website. You click on dashboards, you can click on space weather enthusiasts, or click on Aurora and get quite a lot of information. I'll show a few examples. So here's a KP index for the past 3 days. I showed this earlier, I think, maybe I did, maybe I didn't, but shows quite a lot of detail. If there's a major solar flare, it'll show up right here. If there's an X-class flare, this graph will jump up into the X range, and it's pretty significant because it may cause a solar disturbance that may be in a solar wind that, if it's oriented just correctly, to come toward the Earth and have negative pointed magnetic field. Everything else is just correct. In that big, huge spiral of solar wind that's flowing away from the sun, may or may not reach the Earth. All their computer forecasts may indicate there'll be a big disturbance, and it may just miss the Earth, or it may hit it and cause a big impact. We don't know, and forecasts are not really very good. So this is why I'm going to do a last-minute forecasting based on numbers I can find on this website or some others. Anyway, just wanted to illustrate. That's one detail you can get. Here's another detail you can get: three-day forecast for KP index. I've mentioned a few times it's not 100% accurate. However, all the websites and apps I looked at take these numbers and project them as if it's gospel. So, okay, fine, that's one way to do it, because the non-physicists will say, just tell me, is it going to be aurora or not? And is the KP index going to be 5 or 6? That's one way to, it's a very rough approximation just to look at these numbers and say, okay, go with that. So anyway, that's available on that website, or any website, really. Here's another product you can get from there, an SD Aurora forecast. Slight complication, you can get a half-hour forecast, and half-hour forecasts are fine. They're pretty good because whatever is measured at those spacecraft that I mentioned will flow in the solar wind, which is approximately half-hour upstream from the Earth. So whatever is real-time being measured at the spacecraft will impact Earth roughly half an hour later, depending on the speed of the solar wind. So fine, a half-hour forecast, Aurora forecast is fine, but I've found this things can change in half an hour. So it just can suddenly turn to red when it suddenly becomes aware somehow that Aurora is developing faster than predicted. And that's okay. Me being a meteorologist for the past 20 years, I can assure you that not all forecast models are correct, and things can change. And you can see a forecast for clear skies, cloudy skies, rain, thunderstorms, and models are imperfect. Forecasters are imperfect. Things can change in half an hour, right? So, okay, fair enough. It's not perfect, but I don't tend to rely on it too much. Oh, there was one detail I wanted to point out. Well, I had that. Nope. Back up. Who we back up here? Oh, neat. I think. Oh, yeah. So I put a note in the top right corner because I'll refer to it later. One other detail I want to look at. It's actually marked off. You may be able to read it, may not. Hemispheric power index is marked off here as predicted or it's indicated. I think here I can barely see it. It's around 33 gigawatts. And for a strong aurora or a reasonable aurora, I want it to be around 40 gigawatts. So skipping a lot of details, it's just the amount of energy being dumped into the atmosphere by the aurora, or at least by the solar wind particles pouring into the Earth's magnetic field. Okay, I just wanted to point that out. Another, you can get more predictions of solar wind prediction, and it's pretty darn interesting, and it's actually a movie. If you click on here, you'll see it scroll through here, and stereo A and stereo B are two other, but the point here is it's got its own forecast of the plasma, of the density and speed of the solar wind for next several days. So that's pretty handy, although again, it's not perfect, but when you see a big hump coming where it jumps up, that would be a detail to watch out, that there may be a good chance for Aurora if everything else is lined up. I said they're not, websites are not all really good. So there are some that are a little bit imperfect, such as this one. I got this today. I said, what the heck's going on here? What's this 7? And what is this number that they're getting? Where are they getting it from? Where is it currently 7? Is that the KP index? I don't think so. Because the current KP index this morning is 3. So where are they getting these numbers, and what the heck do the numbers mean? So these guys here, to scroll up higher up here, it's auroraforecast.com, or it was the same one that Arnold mentioned. What the heck's going on here? So my point here is, watch out, be careful. Decide what you're looking at. Anyway, back to my preference, what I decided, I told you it's my perspectives. And so my perspective here is to look at the solar wind for the past 24 hours, see what I think if there'll be any reasonable chance for Aurora. And yes, I mentioned earlier, BZ is negative. BT is pretty weak, actually. It's not very strong, and BZ is not really strongly negative, and speed is way up there. It's around 500 kilometers per second. I don't really see any density shock wave. So despite all this conditions being quite buzzing around and quite hopping around for the past 24 hours, I wouldn't, it's not any chance for Aurora, especially not while KP is fairly low. And here's past 30 days, and I don't think there's anything I wanted to point out here that I didn't point out earlier. I pointed out this interesting period here, so I think I'll skip that. Just to point out, you can get the past 30 days, or quite a lot of past data, but the past 30 days is very useful for considering the past month, what's happening. And I'll show you what I mean when I talk about coronal holes. In that case, the speed, oops, I should back up a little bit. If so, I should point out just in that passing that the speed was pretty fast here around end of March. So if I think I have a picture of this again later. So just one detail to point out, solar wind speed was pretty high last few days of March. Anyway, so some other websites give nicer, easier to read illustrations. So another one of these websites, it's a more readable version of this same data that's from the SWPC. It's just plotted for the past 3 days. It's just a nicer, easier to read, maybe, interpretation. You see, speed is more delineated here, and can you see it more information at a glance. So just to say that there are some other websites that have good presentations of data. So I picked this KP index of 1 of April 1st, and didn't want to go into too much detail that I haven't already explained. Didn't want to go on too long about a whole lot of details, so I think I'll just skip that. I think that was what I showed you earlier, that information. Oh yeah, I wanted to show out this detail here because I'll go back to this as a very good example of a very rare situation that occurred and why I didn't expect it. Why I thought, forget about your Aurora forecast for that Thursday night. And that was because earlier in the daytime, these guys had this forecast out showing pretty high numbers for the Thursday night. So I sent an email to the Toronto Centre Forum saying there may be some chance for Aurora tonight. However, I decided around sunset, pretty slim chance because it began earlier than expected. So already in the afternoon of March 23rd, KP index had jumped up to 7. So quite a significant magnetic storm is already underway in the afternoon. Whenever I see that, I figure it may last a few hours, may last 3 or 4 or 5 hours. So by the time sunset comes, it'll be diminishing. It'll be a waste of time to even worry about it. However, it was clear that night, so I went out anyway. Stargazing, I had my own list of observations to do, but I was surprised because it did blast up, continue on. So that was a long-lived geomagnetic storm. So it was quite a rare situation, but it just shows the advantage of looking at past data. I want to know what happened hours earlier in order to decide what will happen in the future. In this case, I decided it was pretty darn active in the hours earlier, and I decided to write it off for the next few hours. Anyway, so that's one good example of a blown forecast, but the value of looking at previous data. So just as another illustration of some websites that have some pretty good data presentation, the solar wind density, remember I mentioned it, shockwave, it shows up really clearly here. It shows up really sharply, and this is the Thursday afternoon. Shockwave came, and then I showed you the KP 7 or 8 that blasted up after that. That's density. This one is total magnetic field. It jumped up to about 20. That's where I like it to be for significant aurora. The BZ went strongly negative, and it's around -10 or lower, went to around -20. So you may remember I mentioned, or I think I have a summary at the end pointing out, I wanted to be around the area of -10. And just as I mentioned earlier, right about now, this past couple of days, it's been around -3, maybe -5, and don't really worry about it too much. But -10, that turned into a pretty good aurora. Here's a detail I wanted to point out. Taking the total break from all of what I showed you earlier, when you have coronal holes, because they tend to repeat on a 27-day rotation cycle of the sun, they last for several months generally, or they can last for several months. This is one way of forecasting that I used about 30 years ago, and I decided in the past couple of decades that solar activity is decreasing. There's quite a lot of evidence I'm aware of for that, and so I really thought that what happened a couple of weeks ago would never happen again in my lifetime, but it did, of course. But so anyway, coronal holes illustrated here. Nice, colorful, pretty picture that doesn't show you much unless I tell you that this is the coronal hole, and this is another coronal hole in another particular wavelength. So details don't matter so much. That they are big, huge coronal holes, and they allow a fast solar wind to stream out away from them. And as I said, if it's Earth directed and oriented just correctly, it could have a big impact on Earth. Solar flux, I watched solar flux very carefully, and solar flux goes approximately in parallel with the sunspot cycle. And so it's increasing quite a bit lately. So the numbers are around 150 to 175 this past month or so. They've been as low as 75, and that's significant because I'll show you probably the next slide here. Maybe not this one here, but is that mentioned here? What was I going to show you here? I think I'll just skip that. I think I showed you that earlier, and I mentioned a few details, so I think I'll skip that. So this is a piece of paper I pulled out from my notebook from about 30 years ago. This is what I used to do before there's any solar wind data coming from satellites. Before those satellites were launched, I listened to shortwave radio. I copied down these numbers every day, the AP index, daily AP index, Boulder ANX, and the solar flux. And I put it down on a sheet of paper, and I graphed it every day. And you may be able to see this little graph here. So this was solar flux increasing at this particular time of this month in October. And the chart range is 154 to 272 solar flux units. And so the point is that's much higher than it is right now, around 175. So it has been much stronger in the past. So even though right now I see solar flux increasing, it's still tiny compared to what it was 30 years ago. But this is what I did 30 years ago. And some of you may remember in the early 1990s, we had a lot of strong, powerful aurora. So in this case here, using the method of saying coronal holes repeat every month and use that as a forecast method. So the point being that solar flux increased here, probably due to coronal hole at this time of this month, coincided with strong AP index or strong geomagnetic activity here. I put some asterisks on here which marked off major solar flares that were also reported on the radio. This is even before internet existed, I think. But anyway, this is what I did 30 years ago. So I use this method, and so I think I have one slide. Oh, I know what I was going to show you. I know what I was going to show. To repeat it again, you see this strong solar wind speed here, which I mentioned a couple times already, but was over 600 kilometers per second around the last few days of March. So if this is due to a coronal hole effect, then don't be too surprised if that repeats again around the last week of April. And so in this case, using the coronal holes, just based on what I did 30 years ago, I don't really care what the BZ is or how fast the solar wind is or how strong the magnetic field is, because I didn't care 30 years ago because that information was not available. I just said a recurring coronal hole coincided with strong geomagnetic activity. And so I wouldn't be too surprised if there's some increasing geomagnetic activity and high solar wind speed, again, around the last week of April. So there's one prediction. So I said it's totally different from using the government-issued KP index. So I think that's all I wanted to show you. I finished off with a few slides of predicting some forms of aurora. So I might as well finish off with that. So initially it begins as a homogeneous arc, and you may be able to pick out here a light green band here. It's another example of a photographic aurora because it was visually white. And this was from March 23rd. I went to an aurora viewing spot and I decided I'll watch for it to develop here. I sat for 15 minutes maybe and I thought, not much happening, but there's a very weak homogeneous arc, and it may blast up, but I'm not going to waste time because I already wrote it off. Remember, I saw the strong geomagnetic storm earlier in the daytime, and I said it's finished. It's not going to do much now. So I watched this, and nothing was happening. So went home, do some more observing. Homogeneous arc. So typically, when you see that, it may develop after an hour or so into rays and curtains. So here you see some rays or curtains blasting up, developing, and becoming quite energetic. And this may last 15 or 20 minutes, or it may last for an hour. On March 23rd, that Thursday night lasted around 15 to 20 minutes, and it diminished a little bit. But I have seen it in the past when there were strong auroras 30 years ago, go on for an hour or two, strong blazing curtains and rays like this. But anyway, that's following the homogeneous arc, and after it's diminished a little bit, typically you see sheets shimmering across the sky. That may last a whole rest of the night, or it may last an hour and gradually diminish. This one right here is from that Thursday night and Friday morning. You may be able to pick out a hint of some color in the sky here, but from my yard. But these ones from 30 years ago were pretty strong with color, intense color, and they were pretty bright. I haven't mentioned what causes the color because it's some chemistry related to the fluorescence of the upper atmosphere. Don't want to get too distracted on that. The point is this may persist for a little while, so you may see that, and then it may progress to some other forms. And I've got a nice little picture here from the Observer's Handbook. But you may see a corona overhead, and it's sort of a nice illustration you have over right here. But it's basically when rays converge directly overhead, or actually high in the south, a little south of Zenith. You may say it's pretty darn weird to see pulsating spots high in the sky, especially 3 or 4 in the morning after a major aurora display. You see aurora has all finished, and you look up in the sky and you see flash, 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 flash of faint gray light. It's not very bright. See what the heck's going on here? But it's okay. Frank just told you that there's pulsating spots as one of the aurora forms. And you may see flames that are shooting up, and a good illustration here again, you see flames popping up every few seconds from the horizon, and there's generally not very bright. And then sunrise, because it's pretty late in the night by that time. So in summary, I really prefer to see the big picture rather than look at numbers like the KP index only. And I really want to see some numbers I pointed out already. They're summarized right here for what I want to see in a solar wind before I think there's any reasonable chance for aurora. So all this stuff has to happen. And I mentioned also if it's following a density shock wave like illustrated for the March 23rd event, that's pretty handy too. That's a very good forecast feature to see. And I told you my own method, which I wrote off. I thought I'll never see again in my life, but this past event may be a resurgence of the major coronal hole stream method forecasting auroras every month, if they occur, regardless of what all the numbers are. So anyway, that's that, and I've finished off here. I just listed some resources that are pretty handy, and I'm finished. So thank you for your time. If there's any questions, I'll try to answer some.
So we have one question from Kyle, who asks, is this available with hourly data, the data from the Aurora? I sometimes image the sun and would love to match the data with the time I was imaging.
The answer is yes, but not hourly. It's minute data. It's 1 minute data. So if you were to look closely at those graphs that I showed for data of a solar wind measured by a spacecraft, they are 1 minute data. So they fluctuate on timescales of 1 minute. And that's pretty high resolution, in my opinion. It's pretty handy because some solar features may be aware of that someone may photograph may last only a few minutes. And you may see them visually too if you're looking with, say, an H-alpha filter. Some of you may have seen solar flares erupting. Pretty rare thing to see visually, but I saw it with a little Coronado maybe 20 years ago. But it's really neat to see a solar flare erupting. For a few minutes, you see it snaking across a bit of a sun's surface. And so we're talking about a time scale of a few minutes. So the questioner may be talking about imaging the sun for some feature that lasts a few minutes. And so the answer is yes, but the data I showed are solar wind data measured at the location of those spacecraft. And time from the sun to reach the Earth is generally 2 or 3 days. And so the data that I showed is not really coinciding with what you see in the sun. It's what's being measured at the yellow one Lagrangian point, about half hour upwind of Earth, you could say. So it doesn't really coincide with the sun. Solar data is a total different kettle of fish. Arnold hinted at some information. I decided to skip it because it's a huge, huge kettle of fish. But there is a lot of solar data available, but it's not what I showed. So it's an interesting question. 1 minute data is available, but it doesn't really coincide with what you can image on the sun.
Thank you. And that's our questions for this evening.
Frank, when I finished my talk, there was a question about what do we see down south? And I supposed, and I'd like to know if I was right, I said that if we get an aurora in the northern hemisphere, you're going to see one in the southern hemisphere, and they will be like similar. Was that right?
Yes, according to textbooks, it is quite correct that the northern and southern auroral ovals are mirror images of each other. I'm not totally sure, and that's a good question to research, because there are some anomalies in the Earth's magnetic field, such as the so-called South Atlantic anomaly, which is a very interesting study by itself. So there are some imperfections in that mirror image idea, but that was the old textbook idea from even 50 years ago when Aurora was studied quite extensively. It's tricky even to try to compare Earth orbiting satellites or even GOES imagery, or of the old-fashioned, what we call them, space shuttle imagery, because by the time they reach halfway around the world, it's a good 45 minutes later. So that's not really comparable. But it's a very interesting question to research, but I don't know, it's a good question to discuss. Anybody have any discussion like Chris?
So the aurora ovals are centered around the Earth's magnetic poles rather than the Earth's axis of rotation poles. So if the magnetic pole in the northern hemisphere is, say, in northern Canada, sort of south on our side, the southern magnetic pole is going to be offset on the other hemisphere. If we're in the eastern hemisphere, they'd be on the western hemisphere, so that the direction of the ovals will be offset in that sense. So it wouldn't be quite a mirror in that way. It might be 12 hours later that it matched, in other words.
Okay, good point. So it's not a mirror image geographically, but magnetically it probably is. Good point. Yeah, it's an interesting question.
Good. And more questions?
Oh, have a fist fight.
Okay.
Over who gets to ask the question.
Hey, Frank. I was wondering how much of a risk does the aurora phenomenon or related phenomenon have for satellites, power lines, computer chips, things like that? I have heard that for large corona outbursts that they've closed down satellites and shut them down to shield them against hazards posed by the sun. Are these associated?
Yep, 100%. Good question. I decided to leave it out. That's such a big field. I actually started off, I threw out a lot of slides, but one was showing the impact of why does aurora matter. And the aurora forecasting is only one trivial part of the geomagnetic effects. So they influence power lines and pipelines. They induce currents in them. Back in the first huge aurora of the 1990s was 1989, and it blew out a lot of transformer equipment in Quebec long transmission power lines. And it convinced a lot of power companies that they got to upgrade their equipment to be resistant to that sort of problem. This happened elsewhere in the past, but that's also trivial compared to effect on expensive satellites. Some have been conked out by it. A good example of the increasing a recent launch of what do you call those pesky satellites? Starlink. So I launched a set that got launched, had got scrapped and got burned up in the atmosphere because it couldn't be raised to high enough orbit in time, and they reached increasing density. So I thought in that case, good, we hope for more geomagnetic storms that will take those suckers out. But the point is, that's trivial too. I think reason that the U.S. government made about 10 years ago, made Space Weather Prediction Center, and it used to be called Space Environment Center, made it a part of NOAA, Department of Commerce, because there's huge resources that they could lose. I didn't put up pictures of, you go on the website to see different effects. They've got pictures of farmers in the field using GPS to plow their fields, and other things that rely on GPS. And that's all trivial. If you put up a picture of a warship or something that the U.S. government spends big money on, not to mention a lot of things they have flying around and a lot of resources they have tied up that are really strongly dependent on geomagnetic storms. That's one huge thing. Another huge field I'm aware of is manned spaceflight. That's a slight challenge, to put it mildly, for people expecting that they'll send men to Mars or people to Mars. I think I don't know any solution to it. Be interesting if anybody here has heard of any solution to it, but I think it's a mostly insurmountable challenge to how they'll deal with the risk of solar storms. And it's rumored that the Apollo astronauts were very, very lucky that they didn't get blasted out by a solar storm. They didn't even know about them. It was really only 1975 when I remember Skylab was orbiting, and it discovered a lot of these interesting things that were unknown before then. So I'd say the U.S. government's huge resources that they have dependent on communications and stuff, and spaceflight, or human spaceflight, are probably the biggest consequences I'm aware of. But yes, expensive satellites get conked out or they're at risk. One of the SWPC's categories was for satellite operators, and they have, you can pull up some graphs and charts showing the satellite charging effect of the charged particles coming into the atmosphere, because it's always in flux, always changing. It's not zero, there's always some amount of charging going on. It's always influencing radio. It's always influencing, to some degree, communications, like aircraft try to fly across the pole. Sometimes they can't. Sometimes they have to make expensive detours around North Pole because of lots of communication. So there's a lot of expensive consequences due to geomagnetic storm effects. So short answer to your question, yes, hugely expensive problem. And aurora forecasting is just the most trivial aspect of it, but they're nice enough to put up information for what they call space weather enthusiasts and aurora watchers.
Thank you very much, Frank. Very informative and detailed presentation, and I actually learned a few things myself. Even though I've been observing the aurora for a long time, I always relied on the KP index. Now I know better. Thank you very much. And also, I didn't have a chance to thank our previous speaker, Arnold. Great graphics and animations, really helpful and very well done. Thank you for coming to present to us. All right, so that concludes the speakers for this evening. I'll call on Tom Luton to take care of the announcements. And we're going to go to a short break. We'll be right back.